Okay, in this lecture we're going to talk about quadratic equations. This is the next order of complexity for a mathematical model. A quadratic equation, the standard form, is ax squared plus bx plus c equals 0. Right, so notice that the highest exponent here is degree 2. Okay, and so we have a quadratic. Notice that this is an exponent of 1 here, and this is like an x0 here. So a, b and c, of course a can't be 0, but a, b and c are real numbers. Alright, so it's what we call a second order polynomial, or second degree polynomial. Alright, so, and this is therefore forms a second degree equation. And we want to know how can we simplify these equations. And the more important question is when, what value of x, satisfies this equation. So our task here is to find the x value or values that satisfy this equation. Right, now there's a number of different methods to do this. Alright, now the first one we're going to talk about relies on what's called the zero factor property. Now the zero factor property works on the basis that if I have a and b, alright, which could be complex numbers even, okay, then if I have the product of these two numbers is equal to 0, then clearly either a is 0, because a 0 by b would be still 0, b is 0, in other words a times 0 would still be 0, or both a and b are 0. Alright, now if that's the case, what we want to do then is we want to see if we can factor this into two factors that are multiplied together to equal 0, and that will allow us then to solve to find the value of x that causes this to happen. Right, so let's look at some examples. So this is why we had you work on factoring, because this is going to require factoring skills to do this. So let's suppose I have 10x squared plus x minus 2 equals 0. Now to solve this I'm going to use what's called the AC method. Alright, and you can see from ax squared plus bx plus c equals 0, I have a is 10 and times c, which is negative 2, I end up with negative 20. And then I want the factors of negative 20 which add up to 1, which is right here, the 1 in front of the x. Of course I know what that'll be. That'll be 5 and negative 4. So what I do is I get 10x squared, I break my x here down to a 5x minus a 4x, that gives me the x minus 2 equals 0. I take out a 5x here, so I'll have a 2x plus 1. I take out a negative 2 here and I'll have a 2x plus 1. Make sure you're clear on the signs. Negative 2 by 1 is negative 2 is 0. Now I can take out a factor of 2x plus 1 and I'd get a 5x take 2 equals 0. Now notice that this would be my a, this would be my b, so this implies then that 2x plus 1 is 0 or 5x take 2 is 0. Which means that 2x is equal to negative 1. We're now just solving linear equations, or x is equal to negative a half, or I have 5x equals 2, or x is equal to 2/5. And so my solution right, is simply the set -1/2 and 2/5. Okay, so that's how we do that particular type. That's using the zero factor property, so that's our method 1. So method 2 is for certain quadratics that may have a bx missing. And this will use what's called the square root property. And the square root property says this, that if I have x squared is equal to k, then what I have is that x is equal to the square root of k, or x is equal to the negative square root of k. Okay? Alright, so for example, alright, let's suppose I want to solve each of these quadratics. Let's suppose I have x squared equals 31. Then this implies that x is equal to the square root of 31, or x is equal to the negative square root of 31. We sometimes write this as x being equal to plus or minus the square root of 31, and our solution would be plus or minus the square root of 31. Alright, part B. Let's suppose I have x squared is equal to 64. Then this implies that x is equal to the square root of 64, or x is equal to x is equal to the negative square root of 64, which implies that x is equal to 8, or x is equal to negative 8. And sometimes we write this as x equals plus or minus 8. And this would be our solution. Alright, we could either write it like this, or we could write it like plus or minus 8. Okay? Alright, if we get a little bit more complexity into it, let's suppose that we have x minus 8 squared is equal to say 72. Okay? Alright, what we'd have here, this would imply, now instead of this just being x here, we've got an x minus 8 squared, but we can use the same principle and say, well, x minus 8 must be equal to plus or minus the square root of 72. Okay. Now to solve this, this implies then that x is equal to, if I add 8 to both sides, 8 plus or minus the square root of 72. Now we need to simplify this. This means x equals 8 plus or minus the square root of 36 times 2, which will be 8 plus or minus 6 square root 2, and so that would be our solution. Right, like so. Okay, so that's how we do two methods for solving a quadratic equation.